Well, thanks for joining us, everyone. My name's Ron Wakefield. I'm the Vice President of CIB. I'm sorry I'm not the President, but I have to be a secondary substitute for him. Hopefully that doesn't detract at all from tonight's excellent presentation or this morning's excellent presentation, depending on where you are. It's night for me. So our speaker today is Heikki Ihasalo. He's got a DSc in technology, and he's the Innovation Director at Granlund and a Professor of Practice at Aalto University in Finland. He's got over 20 years experience in research, development and business leadership across academia and industry. His research focuses on smart buildings, building analytics and artificial intelligence. He currently leads the AI Champion Research Project at Granlund, which aims to boost productivity in the construction industry by 10 to 15% through the deployment of 100 AI agents. He's going to speak to us tonight about applying AI in building services from design to operations. Over to you, Heikki.
Thank you for the introduction. It's a pleasure to be here and to share you some thoughts on AI. Yeah, I'm going to tell about the AI applications that we have developed in Granlund, and they come from the three phases of the building life cycle. So starting from the design to construction and operations. Below you can see the 8 applications that I'm going to tell more during my presentation. But before going to these examples, shortly about the organizations that I work with. So first about Granlund. It was founded in 1960. The services that we provide are MEP design, structural engineering, architectural design, consulting services, both for the construction and operation and maintenance phase, mainly concentrating on the sustainability and energy side. Then construction management and software solutions for the property management and for project management. We have 1,800 employees. Offices here in Finland, Sweden, Netherlands, and in the UK. Net sales last year 180 million euros, and customer satisfaction in PS is in 94. And related to innovations and R&D, we invest around 6% of our net sales yearly to innovations. Then the one slide of the Aalto University, established in 2010. It was like a merger of 3 universities here in Finland, Helsinki University of Technology, Helsinki School of Economics, and University of Arts and Design. So we call it like an innovation university. So it combines the business, technology, and design together. We have a faculty of a bit over 5,000 persons, students 16,000 persons. And there are some like rankings of Aalto University. In overall we are a bit over 100 in the rankings, but in some certain areas, for example in the arts and design, already in the top 10 globally. I myself work in the Department of Automation and Electrical Engineering, focusing on smart buildings. And also in that area, recently, a lot of work related to AI. And then back to Granlund and how we utilize AI. I would say that we divide the AI applications into 3 areas. The first one is these general LLMs, like multi-purpose models that we use in our everyday work for writing, for translations, doing summaries of the text, so using Copilot, Claude, and so forth. The other category is AI in the software products. So there are coming more and more AI features to our existing software. For example, the Autodesk software that our designers use. And then the third area is these tailored AI solutions that we have developed ourselves. And about those, then I'm going to tell more today. So first the design phase. And here's an example how we started developing our lifecycle analysis AI solution. So we typically first go through the existing processes in some certain service. And this is like a high-level description of the LCA assessment service. And here on the coloring, you can see the like the orange ones that are still manual steps for us. So there's a human doing the work, and the dark green ones are those that we use AI, and light green ones that we see that the next step is for AI. So starting from the project kickoff, so using AI for collecting the project basic information from different kind of like data sources. For that we use AI, and then especially for the data collection for the LCA calculations. So extracting data from BIM or different kind of like PDF documents and drawings, and calculating the amount of materials and quantities and areas from the drawings and PDFs. But still, we have the human in the loop, so doing the quality assurance there, and in the same there in the LCA calculation part. So still some work for the human to make the quality assurance, but there as well we see that in the future, based on like a benchmarking on the previous project, we could also utilize AI. And yes, also like a more detailed description of what we do there. So for the AI, we have a different kind of like input sources are these PDFs, IFC models, Excels or floor plans. And then the AI then extracts the information that is needed for the LCA calculations. It can also classify the materials to this kind of like a Finnish material classification, Talo 2000 system. And then we still have the human in the loop expert making sure that the AI has extracted the right information. And there's like an ongoing dialogue between the user and the AI. So the AI learns from the expert corrections as well. So if it hadn't like extracted the right information, it learns then and does better next time. Below are some key statistics that what kind of savings and benefits we have got from using the AI solution. And this is like one example of the user interface of this LCA AI tool. On the left-hand side are like one example of an structural document, and then on the right-hand side is the information that the AI has extracted from the document. So these documents could be like, let's say 50 pages, and then previously it was our expert that manually wrote down the materials and the sizes of the materials to the Excel, but now the AI does the extraction, and then on the right-hand side you can still make sure that it has read the right information. And for example, there in the document, you can see the highlighted square area. That is the information that the expert is at the moment taking a look at. Then the other tool for the design phase is an energy load prediction tool that we use in the really early phases of the design. In a phase that we only knew really little about the buildings. Let's say we only know the building type. If it's like a neighborhood or building block, it could be like 20,000 square meters of residential buildings, 5,000 square meters of office buildings, 1,000 square meters of commercial buildings, and based on the simulations that we have done for hundreds of buildings, we have created this AI tool that it can then calculate based on these only like a small information about the future buildings, the heating, cooling, and electricity loads. and this information we can then use in sizing the billing service systems and making the cost estimates for the future. So it helps us to really fast to make estimates of the loads and the cost for the systems. And then, for example, compared to previous work that we did, so it was based on like a rule of thumb estimations or then simulations that are more than you need bit more manual work to do those. Third example is Shem AI that we use in the building automation design. So it's used for quality checking that are there any like inconsistencies between the functional description there in the picture on the left-hand side and the control diagram. So there are a lot of like equipment and components in the building automation design, and there could be like mismatches between the written functional description and this control diagram. But now the AI makes this kind of like a quality checking and makes sure that we have all the components that are mentioned on either of these documents. Now that was the design phase, and the next examples are from the construction phase. There we provide construction project status reporting to our customers. And on the top, you can see the previous like workflow. The expert having spent a lot of time of collecting information from different kind of like meeting minutes, from the sub reports, from different kind of drawings, and less time was then utilized on analyzing the report and doing this kind of like recommendations for our customers. But with the AI, in a similar manner that was in the LCA AI tool, we can use the AI to collect and extract information from different kind of documents. And then there the expert can concentrate on like, okay, first making sure that the information is accurate. So doing this kind of like a quality control, still having the human in the loop, but then concentrating more on the analysis of the report results and making this kind of like suggestions for our customers what to do better in the future. Then we also provide different kind of like cost calculations, CO2 calculations, scheduling, procurement planning, logistics planning for our customers. And in that area, we typically utilize information from various design planning systems or from BIM or IFC. That information we collect to our DDM, Design Data Management Platform, and we can perform the quantity takeoff, so we can calculate the components in the project and then start adding from various data sources more information, so like enriching this component information with the CO2 information, with the cost information. We know the location of the components in the building, and also can connect the more detailed product information to this. And for this DDM, on top of that, we have developed an AI assistant for experts that they can then like start asking, let's say, okay, in this example that what is the CO2 emissions for some certain ducts in the project, or what are the costs of the ducts? So it's kind of more like an interactive user interface for consultants. Then the third area is the operation phase. There we use it, for example, in the energy management side. So automatically detecting the consumption anomalies. Previously, it was our experts that went through the daily, weekly, and monthly energy reports and tried to find these kind of like deviations and anomalies from the data. But in the AI solution, it does it like automatically. So we create an consumption forecast based on the historical information on the weather and the consumption. And now then, based on the weather forecast, we can create the forecast of the consumption and then compare the measured consumption with the forecast. And if there are deviations, we can create these alerts. And there also, we are not interested in like a single deviations, more like an reoccurring ones as they are in the picture. So the orange line is the measured consumption, green line is the prediction, and the red dots are the alarms. So you can see that when the consumption is several days above the prediction, then we got the alarms. And in this case, also for the AI solution, we use two models that we combine. So we have like an long-term model that can read or utilize the, let's say, like a previous 2 years data. So we get the seasonality of the building, what is the consumption during the winter time compared to summer, and then a short-term model that we can get this kind of like an daily or weekly profiles of the consumption, and then the result shown here in the figure is the combination. Another area is AI energy survey. In that solution, we read the energy performance certificates, like the content of the certificate is standardized. So we can use AI to read the information from those documents. And there's enough like technical information about the building that we can create a simple energy simulation model. And this energy simulation model is then connected to our database of hundreds of different kind of energy saving measures. And they're like an energy saving potential and the cost of the measures. And by that, we can create for the building like suggestions of the energy saving measures that could be the most cost optimal ones. Perhaps I show the next slide. So here we use an optimization here that in the figure, so in the y-axis are the investments of the different energy saving measures, and on the x-axis is then the energy consumption in the building. So the most cost optimal ones are here on the bottom left corner. So finding from the hundreds of different kind of energy saving measures, we can find the most cost optimal ones for this building and make like a proposal for the building owner that, okay, you could do this kind of like renovations, and by that you can improve the energy efficiency of your building. And this tool is usually used for like large building portfolios. So building owners having hundreds of buildings, and of those, like from the building portfolio, we can then find the buildings that have the highest energy saving potential. And for example, with this tool, we have calculated over 5% of the building stock here in Finland. I think this is already my last example. It's related to heating optimization. Typically, heating here in Finland is done by radiator heating, and it's controlled based on outdoor temperature and local thermostats in the radiators. But in our AI solution, we use the indoor temperature and occupancy data from the building management system. And we have a reinforcement learning agent that then optimizes the radiator network supplied water temperature based on these measurements. And as you can see from the picture, that the new control is more stable. The indoor temperature during the office hours is more stable. But then again, we can gain energy savings as we lower the temperature during the off hours, so during the weekends or during the night time. And as it is like this kind of like a reinforcement learning agent, it's really good in that sense that it learns all the time as it gets more measurements, and will provide better indoor environment and better energy savings during the time. So these were the 8 examples that we already have in ground. Some of them are still in piloting phase. Some of them are already commercial products. But I would say this is only the beginning. We have this new AI champion R&D project that started last December. It's a 3-year project together with Tampere University and Oulu University, and other industrial partners are Koya and Fira. And it's a 20 million euro project. And during the project, we will develop 100 AI agents for the supply chain of the construction project. And the idea is to gain these improvements in the productivity, as there's a lot of work done manually at the moment. For example, the data is shared using PDFs sent by emails. So our idea is to utilize the design information in a more like a digital format, that it could be then shared between the IT systems, between the different stakeholders during the construction project, and by that gain the better productivity. And at the same time, if we have the data available and if we know more in detail what kind of components there are in the building, we can start steering the sustainability, the CO2 CO2 emissions related to these components in a better way. And then we see that it's going to improve the environmental point of view of the construction project as well. And it also enables industrial construction. So as we know in more detail that when the components arrived at the construction site, where they are located in the construction site, when the components were installed and so forth. So we really know in more detail what's happening in the construction site. So that's also the benefit of this project. Those are my examples on how we utilize AI in ground. Happy to answer to your questions, and if you have any comments and questions, you can also contact me later on from that email address or from LinkedIn.
Thank you very much for that very interesting and comprehensive presentation. I'd ask people who want to ask questions if you can raise your hand with the Zoom tools. It will help me see who's asking the question. We'll give some time. No one really wants to ask the first question.
Yeah, that's true.
Professor.
That's not the Zoom hand, but we'll accept. Mogs, you going to ask?
Okay. Thank you so much, Professor. Thank you so much for the wonderful presentation that you have made, Heikki. It's quite practical and interesting presentation. One of the questions that I have is with the involvement of such kind of AI applications during design and construction, there is a very real concern from graduates that the need for the and consultancies will significantly be decreased. And the skill that the industry is requiring is quite different from the traditional way. So, how do you think should the universities restructure the graduates can fit into the future of the construction industry, which is very dynamic and some of the things are not predictable in the long way because it's still evolving and some of the technologies are quite dynamic. The second question with respect to you have showed us some of the areas that still requires the actual, but
The connection is a bit lacking.
for some
Yes.
aspects. So, how do you see what's the future? What's your observation, and what do we expect from the universities? Thank you.
Thank
So,
you.
Heikki, do you think you have the questions okay? There was a lot of pausing in there.
Yeah, at least the first one. If I answer that first, and then we can continue.
Good on you. Thank you.
Yeah, it's a really good question, and at least like in our company in ground, we are like hiring more persons. So like AI is not taking their job at the moment, and but it's like for the young talent, it's really important that they also already during their studies try and like learn how to use AI, like in their studies, in their work. It's going to be the like really like big part of the work of tomorrow, how to utilize the different kind of like AI tools. So yeah, be active and try and learn by doing, I would say so, to use the like to get the benefits of different kind of like AI tools.
And the second part of the question related to your advice for universities in terms of preparing graduates. So,
Yeah, I would say the same thing that okay, just try the tools and be active and yeah, that would be my advice.
all right, fantastic. Thank you. Thank you for that answer. Other questions? Emma.
Hi, Ron. This is Emma from Nelson Mandela University. Remember me?
Yes, of course I remember you.
Awesome. Awesome, Ron. I just wanted to comment. I've been involved in, of course, my focus area is engineered wood products. So I just wanted to find out from Heikki. I hope I'm pronouncing your name correctly, Heikki. Sorry if I'm not.
It's good.
Um, the software in particular, is it just focused on traditional building materials or does it also cover alternatives such as wood? That's the first question. The second one is probably links to the question from, is it Mogus? I'm sorry if I'm pronouncing your name incorrectly, but what we've noticed, well, throughout in my academic life, of course, even as a lecturer myself, is that there's a hunger from students to use software and technology and so on and so forth. But now, of course, if the software is readily available, if there's like a free to use version, then students are more inclined to explore. So very much from us in the on the African continent, Have you reached out to some institutions on our side? Is there some sort of a plan to get maybe some of our institutions to tap into the software and to actually expose it to graduates? Just linking to the previous question, because we find that we need to produce industry-ready graduates, but we cannot if the graduates are not exposed to the software. So, is there some sort of an opportunity to expose our students to the software so that they may become industry-ready? Thanks.
Okay, good. The first question, in our DDM platform, we can utilize both the MEP information as the structural information. So that's the main materials and components of the construction project. And related to the school university collaboration, we would be happy to collaborate. And as there was in the one of the first slides that I had, that we divide these utilization of AI into these common tools like ChatGPT, Copilot. Then we have the AI features that are embedded in the existing software, and then these our own development. So I would say that absolutely in the everyday work, people are using more and more Copilot, for example, in a company. There are coming these features to Autodesk products, and then I would say that the students should also try those. But perhaps the most development work on our side is on these things that we develop to ourselves, to our experts, or to our customers. But would be happy to do cooperation with schools and universities on these areas as well. So please be in contact.
Thank you.
Thank you so much.
Hey.
I will. I've just checked you out on LinkedIn. I'll send you a message. Thanks.
Yeah.
Emma's very enthusiastic from my previous interactions with her. So you can expect to get some questions from her on LinkedIn.
Excellent.
Other questions that people would like to ask?
Hello. Which kind of artificial intelligence algorithms do you use for the models?
Really many different ones, depending on the application area. We started years ago in this kind of more time series based problems, and then for that they are an open source models that we have then trained on with our own data. There are a lot of research papers done in that area, so perhaps through those you can find the best or most suitable models. And then on the LLM side, we use the tools from Azure. So again, ready-made models that we train with our own data sets, and by that get a more specific tailor-made AI solution for use.
Are you using swarm intelligence algorithms such as ant colony optimization?
I would say that I could, if you are interested in more, I could connect you with our AI lead, and then he could tell in more detail. Yeah.
That would be great. Thank you very much.
So send me a message.
Yeah.
Other questions? I have one question that I'd like to ask, if that's okay, as the chair. I'm not sure I have that privilege. You can refuse to answer this if you wish. So I'm involved with a very large consulting company here in Australia that has somewhat similar profile to what you presented. I think one of the challenges, and I'm interested in your opinion on this, is how do you ensure that you only get your own data into the AI models and not not other data? And also, how do you ensure that your data doesn't leak out into other people's models?
Yeah, that's a really good question. We have our own like an AI like an environment within the Azure. In there we can then control the data that is used and shared. And of course, like as we are like a consulting engineering company, the data is like our customers, and we always need to ask the permission of them to utilize it in the training of the AI solutions. So in that sense, we need to like keep sure that it's only used the data that we have the permission, and it's not shared outside. So it's everything like from the IT and cyber security side is then like involved there.
Yeah, I think it's very challenging. Like even in the university, it's very challenging.
It is.
Because
Yeah.
we're sometimes using, there's a temptation to use AI for processing student data, for instance. And if that's the case, how do you make sure people don't use the open models to do that processing and then the data leaks out? It's just an interesting challenge for, I think certainly the company that I work with here in Melbourne and in Southeast Asia, they have a very strong policy in that space, but I still kind of wonder what other people do and how that works, because it's a very new area, but very interesting.
And there's coming more and more regulations. For example, here in the EU is the EU AI Act that then regulates how we can utilize the what kind of data we can have in the training of the models and what kind of applications we can do with the AI. So there's coming more and more regulations.
Yeah. All right. Any other questions before, a last question for Heikki? Or is mine going to be the last question? That's pretty bad if it's the chairman's last question. No? I feel like I'm an auctioneer, going once, going twice. You think? Okay, well, thank you very much. Please join me in thanking our presenter.
Thank you. It was a pleasure.
Very hard to get applause in a Zoom meeting, but you got my applause anyway. And thank you everyone to attend. I hope it was I think it was incredibly informative, and it's very interesting to see what Greenland is doing in Finland and the northern countries. Very exciting, leading the way as normal. So thank you very much for informing us about this.
Thank you.
Good morning or good evening, everyone, depending on where you are.
Bye-bye.
Thank you.
Bye-bye.